Okay, moving on. Right, once you are done with your design brief, specifications and constraints, you will then start with your sketches, okay, of what your design is going to look like. Okay, you don't have to necessarily draw a kettle. You can just draw the circuit that's gonna go inside of the kettle. Right, all of your components must be present. Okay, all the things that you need. Right, so you're going to make 2 rough sketches of your design. Use labels and notes to explain your design. So you're going to draw 2 blocks, right? You're going to draw your first sketch of what your first circuit is going to look like, then the second one. Now, make sure to label it and detail it enough so that if I take one look at the picture, I can understand what's going on without having to ask you. So just make sure that everything is on there, right? It is detailed properly. If your second sketch is an improvement on your first sketch, keep the first sketch but simply label the second sketch as improved design. So you can make your second sketch as an improved design if you would like, but you just need to label it. Okay, now from those two, you can just read this here. Okay, when I do post up the pictures from those 2 designs, if you take 2 different ones, you are going to choose one of the designs, okay, whichever one is better, whichever one you want to try and build, and you will make a final sketch of that design. Okay, and you can improve it if you would like, make changes, anything like that. Okay, right, moving on. Okay, this is basically just telling you stuff about how when working in groups and how your design should be. You can read that on your own. Okay, right, once you have chosen your design, okay, you will do a 2D working drawing and you will do 3D drawings of your design. Right, so your 2D working drawing, right, is the first angle orthographic projection. Remember, that's the one where we did it in term 1. Okay, we had a page that we put in landscape. We drew a border, remember, and we separated the page into 4 quadrants. Let me just see if I can draw an example for you quickly. Right, we had a page, right, and we had a 15mm border. Sorry if this is untidy. Right, and we separated into 4 quadrants, right, equal quadrants, and in this last quadrant we had the symbol for orthographic projection. Remember, it's in your textbook. And in these 3 quadrants we had the front view, side view and top view. Remember? If not, you can take a look in your textbook or message me and we'll go through it together. Okay, so that was your orthographic projection. Right? First angle orthographic projection drawing. It should be drawn to scale and show show as much detail as possible. Show dimensions and the scale. Right? Remember, we use a scale because we can't draw the actual size of the circuit. We need to make it smaller. Right? So we have to reduce it. Okay? And then our dimensions are our measurements. Remember, in technology, we only use millimeters. Okay? Then you have to make an isometric drawing of your design to scale. This means right, that we need to make it the proper size. Do not show the container or structural support for the inner parts of your design. Only show the inner parts, which is the circuit. Do not show any hidden detail, but choose your viewpoint so that as much detail as possible is shown. Show the scale, but do not show the dimensions. Okay, now if you remember from last year in grade 8, right, you had isometric grid paper. Okay, we had a line that goes this way, a straight line. Sorry, I don't have a ruler with me right now. And then we had to draw 2 lines that were 30 degrees from the straight line. Remember that.